I have a bunch of animals that I put together in a cage, and that is what a company is. A market is exactly the same. A market is nothing else. If I take a financial market, stock market, right, is nothing else than a bunch of apes, a bunch of people, a bunch of biological entities that are locked in, if you want to, into a limited space. There are some basic rules that you have to follow, but basically the financial market is created by the interaction of animals that are you, right? That is the market behavior. So if we talk about market behavior, please talk about the reality, which is that you have all these individuals that interact on each other. In less volatile markets, the automobile market, the steel market, you might have the impression that it is less true. If you ever see, and physically you have to go far to physically see a financial market, since the London market is of course completely virtual, Wall Street is probably not yet virtual, so you can go there. If you see how a market functions, you immediately get my point of the biological concept of complexity. Right? I mean, if you ever can see a movie on the floor, the stock market, the floor of the stock market, you'll immediately understand what I'm going to tell you in a while about complexity in biology. There you see it operating. And that is what creates market behavior. Market behavior is nothing else than those 200 people that are locked in the stock exchange with a minimum number of interaction rules and that are going to create a reality. That is the essence of the biological concept of complexity. It will be the essence of the artificial intelligence concept of complexity. As I said in the beginning, you'll see, maybe to your surprise, at least to my surprise when I all started to discover that whatever has been said in physics, what I'm talking about now, what has been said in biology, what we see later on, artificial intelligence, economics, quantum mechanics, all leads to the same things. And the real essence of all that is causality, as Newton defined it, does not seem to hold in reality. Now then the question is, so what? What do we have to do? And then it becomes interesting, since then once you find out that you are part of reality, that means that you have much more possibilities to influence reality. So management is not measuring and anticipating, management becomes creating. Now, that is roughly the physical view. A complex system can have chaos and order, as you've seen in the simulations. A complex system can have chaos and order. Chaos and order are just two states, two possible states of a complex system. You don't have chaotic systems, okay? You have complex systems. And they might show chaotic behavior or they might show orderly behavior. So, the same complex system, and one day might seem completely stable, and the day afterwards might seem completely chaotic. It still remains the same complex system. Self-organization is an essential characteristic of a complex, nonlinear dynamic, a complex system. And he talks about that. So the whole operation of that change in colors is based on self-organization. It is not something which you as a physician bring in the system. The system auto-organizes it. And that of course leads us to the basic concept of autopoiesis in biology, which is precisely that concept. He spoke about entropy. Entropy is nothing more or less than a measurement for disorder. The higher the entropy, the more disorder. The values of the simulation I showed you in previous class, the maximum entropy of that system was 4. Right? If alpha was 4, then you had the highest degree of disorder in the system. If entropy is 0, the system is stable. That means the system contains physically all information. The system is dead. Okay? Now, if you now talk about a company that is kept close to equilibrium, a company that you would be able, it's very difficult, that you would be able to bring to an entropy 0 is a dead company. Which means there's no creativity, there's no innovation, at the end of the day it's going to die out. So if you arrive to manage a company, to control, I don't like to call it management, to control a company perfectly, you're basically killing it. The thing that is important is if you really want to keep your company creative, innovative, you actually have to make the entropy as high as possible. However, know that very high entropy means chaos. So there you'll have to find a balance between as much entropy as possible, however, giving somewhat stable conditions to your company, right? And that's the balancing act of a manager. How can I bring in as much as entropy as possible without putting people into a complete chaos? Know that putting people into a complete chaos will make them creative. Now I move on to biology. The concept of self-organization, the concept of bottom-up creation of knowledge are concepts that will be very, very clearly and strongly present in the biological view on complexity. And I'll talk mainly about two people, as I said. The one is Francisco Varela, and the second one, a little bit younger, is Rupert Sheldrake. So I'll talk about Varela. Know that the theories are co-developed by Maturana and Varela. The basic idea that he brought, and I'll go a little bit in detail on that concept, is autopoiesis. And the concept of autopoiesis is one that has serious consequences for the way you do science, for the way you manage people, for the way you organize organizations. Right? So you have an interest to really understand what they mean with autopoiesis. The one remarkable thing that they did is, instead of studying the evolution of species, what happened in biology mostly, I mean, they took a species and they studied the progress or the changes that took place over time in that species, which of course started with Darwinism. Darwin was the guy who sort of put all the biologists on that trail. The very original approach of Maturana and Varela was basically that they say, no, we go to the basic building blocks, which is the cell. And they studied a lot the amoebas, the one-cell bodies. And they say, and now let us see what happens if we look into the interaction of cells. So they didn't look into species in the evolution of species, they looked in the evolution of interacting cells. Now your body is a big bag of interacting cells, right? Billions and billions of cells you have there. And the operation that you suffer or enjoy in your body is the consequence of the interaction of billions of cells. A Darwinist biologist would look into how people evaluated from a kind of a monkey to a less monkey to a human to... That is what Darwinist biologists would do if they studied the species mankind. They say, no, 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 no. It might look like that. You might look like somebody which is... No, it's one entity. We appear to be one entity. But they say that's not how it operates. If you want to understand how mankind operates, you'll have to go down to the level of cells and interacting cells. Now that is the big innovation, if you want to, that Maturana and Varela has brought to biology. Once they started looking into systems like the body from an autopoietic system, they have observed that an autopoietic system has three characteristics. One, an autopoietic system